So let's see where this formula comes from. Well, the process goes like this. If you've got A, B, and C as your one direction vector, and you've got D, E, and F as your other direction vector, to find the cross product, we want to find a new vector that's perpendicular to these two. So it must have an x component, a y component, and a z component. And to find out the x component, we're going to do the following. We ignore that line. We're going to find out the x component. So we ignore that line, and then we take that product, and from it we subtract that product. Okay, so we've got BF minus CE. That result will give us what the x component is for this particular new product vector. To find the next one, to find the y process, well, we're going to do the same, much the same sort of thing. Only thing is, this time we're going to cross out that line, and this is where you need to be careful. So that was our first step, and that was our second step. Here, our first step is going to go with that product, and then from it, our second step is we're going to take away that product. Okay, so it's going to be CD minus AF. And then we go to the last one, ABC, DEF. We're going to cross out the last line because we're now looking for the Z component. And then we go back to the sort of pattern that we had with the first one. There's our first product. Let's just undo that and do it in red. That'll be our first product, and that'll be our second product. So that's going to be AE minus BD.
Do we have to memorize this?
You need to memorize that process, yeah.
What's it called?
Okay, this is called the cross product, and it finds vectors that are perpendicular. I wouldn't, if I were you, try and remember this little matrix over here. When I do it, I remember this process rather. I think if you try to remember that matrix, it could confuse you. You could quite easily get the letters mixed up. So rather go and get the process fixed in your mind. So have an example of this. Here we've got two vectors. We want to find the cross product of those two vectors. So my x component, I'm going to ignore that line. It's going to be 2 times 9 minus 3 times 8. My y component, cross out imaginary without crossing out the middle line. Where do I start this one? With the 3 down the bottom left-hand corner here. So it's going to be 3 times 7 minus 1 times 9. And then to get my z component, imagine that I cross off the bottom line, and then go 1 times 8 minus 2 times 7. So 18 minus 24 will give me minus 6. 7 minus 9, sorry, not 7. 21 minus 9, 12. 8 minus 14, give me 6, minus 6 in fact. And there I get my vector 1 minus 2, 1. How can I check that? How do I know that that's correct? Being very nice and polite and quiet, and how can I check it? Use the dot product. Okay, so use the dot product of 1 minus 2, 1 dot 1, 2, 3. What do we get? We'll get 1 times 1 minus, or plus rather, minus 2 times 2 plus 1 times 3. 1 minus 4, 3, that's going to give me 0. So that's fine. We know those two are right angles. Try it on the other one. 1 minus 2, 1 dot 7, 8, and 9. That's going to give me 7 times 1 plus minus 2 times 8 plus 1 times 9. 7 and 9 make 16, minus 16 once again comes down to 0. So we've got this vector that's perpendicular to the 2.